Hello, my name is Michelle Stropke, and I am the Riparian Wetland AIM Coordinator with the Bureau of Land Management National Operations Center. The following presentation will cover soil profile descriptions. You can follow along in the section 5.4 of the Field Protocol for Lentic Riparian and Wetland Systems. Soil profiles are an important part of understanding the long-term history of a wetland site. Soils within wetland and riparian areas may undergo periods of inundation, saturation, and resulting depletion of oxygen. By completing a soil profile description, we can determine any hydric soil indicators shown in your soil profile and piece together evidence of what this hydrologic influence has looked like in the past. Materials used for this method include the soil data sheet, a sharpshooter shovel, auger or soil probe, a soil knife or trowel, a tape measure, a squirt bottle, a Munsell soil color book, golf tees for making horizon boundaries, and the Guide to Field Indicators of Hydric Soils in the United States, and other appropriate supplementals for your ecoregion. To complete a soil profile description, you must first find a good location for the soil pit. Try to find a location that is representative of the site, which is typically within the most dominant vegetation community and/or in a location that represents the geomorphic setting of the area. For spoke layouts in homogeneous settings, the default location is within the 5-meter radius circle near plot center. In other layouts, the pit should be located close to plot center in a spot with minimal disturbance. Once your location is selected, you will then excavate the soil pit to 50 centimeters using a sharpshooter shovel. Cut a rectangular area out from the soil, first with shallow cuts slightly wider and as long as the shovel blade. Following the blade of the shovel, cut a rectangular area roughly 2 shovel blades wide on either side. After defining the area to be removed, go around again to completely separate the core from the rest of the soil. Do your best to make sure your pit is fully dislodged from the rest of the soil before pulling the shovel handle towards you to leverage it out of the ground surface. A soil knife or pruners can be used to cut through roots connected to the core in particularly stubborn soils. Try to keep this core as intact as possible as you remove it. If it begins to fall apart, set the excavated soil to the side of the pit on a tarp, roughly maintaining the order of the removed layers. In pits that are especially difficult to excavate intact cores, additional slices of soil profiles may be removed from the edges of the excavated pit to expose a less disturbed surface. Next, identify distinct horizons within the soil profile by indicating with the golf tees where they start and end. Look for distinct changes in soil structure, color, texture, and/or the accumulation or loss of different soil materials, such as minerals. Be careful not to disturb the soil face until you have taken a picture. Tearing away pieces of soil from the underside of the core can help accurately place the horizon boundaries. After determining the horizon boundaries on the soil core, it can be helpful to check these depth measurements with the horizon seen inside the pit in case the soil core became compacted during excavation. Once you have identified the soil horizons using your golf tees, put the tape measure up to the core and take a picture. Make sure to get as close to the core as possible and avoid pictures with shadows across the soil face. Cores that have fallen apart upon excavation may need to be reconstructed to represent the horizon order you observed. A supplemental picture of the soil profile taken inside the pit may help place horizons in this case. Review your image to make sure the picture is clear and the measuring tape is legible. Now that you've taken a picture of your soil pit, begin to describe each horizon. Start by taking the matrix color as well as any secondary redox colors and their relative cover. Cover estimate guides in Appendix N at the very back of the field protocol or pages in the front of the Munsell Soil Color Book can be used to approximate the percent of primary and secondary redox features. Color should always be taken on wet soils, so use your squirt bottle to wet the face of the soil if necessary. For soils with glade horizons, or those that give off a gray, green, or blue hue, color may need to be read immediately to capture the color before iron compounds become oxidized in the air. Soil PEDs can also be broken up to expose new soil faces. Once you have taken the colors of all horizons, determine whether each horizon is organic, sandy, or clayey loamy. Then use the appropriate method to determine soil texture. For mineral soils, use the texture by field flowchart found in the field protocol to classify the soil into one of the 12 soil texture classes. For organic soils, classify by the degree of decomposition into fibric, humic, or sapric organic soil classes. Horizon comments can be used to add additional details of the horizon. For example, to say if the texture could be a mucky mineral soil, or to provide additional information on the pattern of redox features observed. Finally, before backfilling the pit, measure the water depth. For all depth measurements, the soil surface should represent 0, meaning groundwater should be recorded as a negative value from the surface, and the surface water should be recorded as positive values. Measure water depth after allowing sufficient time for the water to infiltrate into the pit and equilibrate with the elevation of the surrounding water table. This may take a particularly long time in fine textured soils, such as clays, in which case you should proceed to other measurements before returning to the soil pit later in the day. If there is enough water in the pit, use the YSI meter to take a water quality measurement before backfilling in the pit. Hydric soil indicators can be determined using the soil profile description of soil color and horizon thickness. Hydric soil indicators will be discussed in more detail in another training video, but you should follow guidance with the Natural Resources Conservation Services guidebook titled Field Indicators of Hydric Soils in the United States. You can also find shortened descriptions of these indicators in Appendix H of your protocol. In some cases, final hydric soil indicators may be determined after filling the pit if the profile description is complete and thorough. There are several measures you can take to ensure quality data collection. These steps are also listed in the protocol at the end of section 5.4. It is recommended to reference these steps during and after a sample event. This concludes the methods for completing a soil profile description. Thank you for listening.